At Sight and Scene, we feature the innovators, disruptors, and changemakers using reality capture technology to drive real impact. These are the people who saw a problem, challenged the status quo, and took action, whether restoring ecosystems, improving resilience, or transforming infrastructure.
They bring a deep sense of responsibility and stewardship to their work, leveraging technologies like drones, laser scanning, GIS, and mapping to create meaningful change. More than just experts, they're storytellers, sharing their journeys and the why behind their work. Our mission is to amplify their voices, educate, and inspire others to push boundaries and take action.
Sight and Scene.
So what might have been an everyday occurrence to go into New York City and look down the street and not be able to see 5 blocks because of smoke and so on.
Yeah.
Now we can see from one end of Fifth Avenue to the other if we have a perspective that allows us to see that far.
Okay, folks, we're live back here in the studio, the virtual studio of Sight and Scene. Scott here for another exciting episode. How you been these past few weeks?
Good. Enjoying the actual warmer weather finally, or at least it's threatening that.
Yeah. Oh man, my folks live in the Midwest. That's where I grew up, and seeing some of these storms that are just tearing through the plains in the Midwest, like central Kentucky is supposed to get like 10 to 12 inches of rain in the next 3 to 4 days. Just man, I went to school in Kentucky, so feeling for those folks down there and wishing well. And we had our spring break here last week. So the kids were out of school. We went camping in Central Oregon in the desert on the Deschutes River right outside of Bend, Oregon. So that was fun, and a little bit of spring. Well, not a surprise, I guess, in spring on the backside of the Cascade Mountain Range. Like you'll get these huge swings. So one day it was like 70, and then the temperature dropped 25 degrees. The wind gust came up to 50 miles an hour, and we got rain and. But you just got to expect that when you're camping in the springtime. But it was good fun just to get outdoors and be with the family. So that was good fun here in the last few weeks for me.
Good. Yeah, same thing this weekend. We had a nice tease of incredible weather, and then it dropped like 30 degrees. So we're so close to like actually nice weather. Yeah,
it's also the season of taxes, so. I've been working on my taxes too, so not so much fun as camping, but it's got to get done. It's another exciting day here at Sight and Seeing. So we have a great guest coming on, Joe Heaney. So we're gonna tee it up here, Joe, for you. I'm gonna give you a quick introduction. Joe is the principal at Walden Environmental Engineering. Joe founded Walden in 1995, along with the marketing and office manager, on the principles of integrity, professionalism, cost-effective services, trust, social responsibility, responsiveness, and profitability. With these core values, Walden has grown to 41 employees and is continually expanding services to meet the dynamic needs of their clients. With his experience and detailed regulatory knowledge on environmental compliance issues and their effect on business operations, Joe provides Walden's clients with quick, decisive, and tangible recommendations for addressing complex problems. Joe has a bachelor's in civil engineering with a master's in environmental engineering and is licensed as a professional engineer in New York, New Jersey, Connecticut, and Pennsylvania. A good day at work for Joe is being able to say he learned something new and different while creating opportunities for mentorship within the company and the broader community. Joe, great to have you on the show.
Thank you.
Yeah.
Happy to be here.
Yeah. Great.
I'll chime in too real quick because Joe, I'll let you tell much more of the story as we go. But Walden Environmental Engineering has been one of Harkin Aero's longest running clients, almost our first client. And so super excited to have you on, Joe. This might be one of my favorite episodes yet.
Thanks. Happy to be here.
Nice to have those connections. So yeah, Joe, do you want to expand a bit and tell us a little bit more about you, about Walden, about how you started, the mission and the key kind of focus that you have within Walden Environmental?
Oh, sure. I feel like I'm doing an interview. I always like to set the scene for the candidates to understand where Walden came from, which is obviously, as described, the start was with me. Many years ago, as a ninth grader, I excelled in earth science,
Mm-hmm.
and my junior high school had never. In New York State, we have standardized testing, and I was the first kid in the history of the school to get 100 on the earth science regents.
Oh, wow.
They weren't quite sure what to do with me, and I guess from there on, I thought I was going to be a geologist until I learned that engineering was the practical application of science. So I started school at the United States Military Academy, spent a year there, and then I went to Lafayette College, 3 years as a Bachelor of Science in Civil Engineering.
Mm-hmm.
And as a civil engineer, I really gravitated towards the water courses, as we called them, water and wastewater and hydrology and geomorphology and so on, and enjoyed that quite a bit. Professor encouraged me to go to graduate school right away. I went to Manhattan College, and at Manhattan, I got a chance to expand on that quite a bit. Uh, Again, I thought I would, at that point, I thought I'd be a groundwater modeler. So
Mm-hmm.
as an engineer, be a modeler, and spent a lot of time with something called Fortran, learned how to program a bit in Fortran. But also while I was in school, we were all given opportunity to work. There was lots of engineering firms in the city New York City, that were looking for
Mm-hmm.
people. So my roommate and I split a grad school roommate and I split a job, 20 hours a week. Each of us worked, and that gave us our sort of first work experience.
That was
I
in
worked.
Manhattan.
Actually, it was in Norwalk, Connecticut.
Okay.
We were running a wastewater lab at a sewage treatment plant,
Okay.
and they were experiencing. We worked for Malcolm Perney, and they were experiencing exceptional process upset. And the management team of the facility were fired, and Malcolm Perney took over, and we were part of that team.
Mm-hmm.
And it was my first real, you know, getting into data evaluation, looking at the data of the plant, what was going on, what was going wrong, and so on.
Sure.
When I finished, I took a job in working for a consulting firm here out on Long Island, where I live, and I was in the public water supply group. And because of my grad school background, there were changes in the drinking water standards. Drinking water standards dropped by an order of magnitude on volatile organics, and I was the only person in the design group I was part of that knew how to design treatment systems for that. So, coincident with joining the company, this opened up, and so I was busy for 2 years doing pilot testing and designing water treatment systems using granular activated carbon and reverse osmosis and so on.
Hmm.
And we call those unit operations. Probably, I doubt I'd be still working there, but I had a bad situation with a boss there. Some of the leadership characteristics that I was taught while I was a cadet at West Point were, directly opposite his behavior. He was a guy who liked to blame problems on his underlings and take successes for himself and not share that with the group and so on.
Mm-hmm.
So at that point, I decided I was done. I didn't want to work at that company anymore. Sort of knee-jerk reaction. I think I'll become a scuba instructor.
little pivot, huh?
Little pivot. Moved to California and enrolled in a program to go from a basic open water diver to an instructor in 3 months, called NAUI College, and I became a NAUI scuba instructor. And from there, I went down to the Bahamas and worked for a while as an instructor and dive master, drove the dive boats, took people out diving and so on.
Yeah.
About 6-8 months of that, realized that I was kind of not using my brain the way I thought it could be used.
Mm-hmm.
So came home, put out some resumes, and 2 years experienced and pretty successful prior to, got hired right away, worked for a company that had a national practice. And, maybe 2 months into it, boss came up to me, handed me a set of airplane tickets, said, "You're going out to California. You know your way around out there, don't you, kid? And you're going to be doing environmental compliance audits of 5 companies." Oh, Okay, and here's a
Nice.
guideline on how to do it.
Yeah, nice.
And that business had work all over the place and varied, and very much different than the firm before, where we were primarily municipal based. This was primarily industrial based work.
Mm-hmm.
So I was doing paper and pulp wastewater treatment designs for paper and pulp mills, and then supporting what they called at the time leverage buyouts, corporate takeovers of which now is kind of, I guess at that point was called like maybe the prerequisite of private equity. This is other people's money buying companies and then rolling them up into bigger companies.
Mm-hmm.
Right.
And we were asked to go out and look at environmental problems at a plant and bracket costs around. Is it less than 100,000 in problem? Is it 100,000 to 500,000? Is it a 500,000 to 5 million, or is it worse than that?
Right.
And very order of magnitude sort of work, but that revolved around stuff that was going on, in Canada and Mexico and all over the United States. I worked there for 6.5 years, learned quite a bit, and had been pushed into a business development role as well.
Mm-hmm.
So I was promoted to project manager, managing clients and projects, and then also developing business. And after a while, I started to see that, there was a little bit more seniority-based promotion system and so on than it was reward-based. So I guess at that point, I decided maybe I could hang my own shingle and see
Mm-hmm.
how I could do. And ironically, we're just about coming up on 30 years of Walden.
Yeah.
Wow.
Something that I hold very dear is I was asked by a scuba diving friend of mine to go on a Western trail ride, horseback ride out in Arizona for a couple of years prior to this. And I decided, I'm a kid from New York. I don't know anything about horses.
It's like city slickers.
Exactly.
Yeah.
And the I guess 6 weeks before I started Walden, I went out on the ride and I brought a business plan along. And the ride is a group of fellas that, ranging, at the time I was a baby compared to the people that were on the ride. I was 30 years old, brought my business plan along, and we went riding out into the desert for 5 days and, sit around the campfire and chat with fellas about starting a business and so on. I got a lot of good encouragement, a lot of constructive discussions, and felt really confident. And, as they say, I offered my resignation, and 3 weeks later hung out the shingle and started Walden. And, I know some of the discussion today, I'll talk about how that went. I know a lot of people I've, let's say, I don't know if it's lectured, but I've talked quite a bit about, some of the formative times of Walden to business owners and groups of entrepreneurs and so on. I think it's really, it was a really great time. It was a really interesting, what you'd say, go time, 16 hours a day of work and little children at home and trying to keep all things up in the air. And, basically started with just myself and I think as you read, a very versatile young woman that could do an awful lot of stuff.
Yeah.
All of which I had no knowledge of doing myself, but I knew how to do the work we did, and I guess I had some capacity for sales.
Yeah.
So
cool. Well, I mean, it's quite a backstory there, Joe. We had from engineer to scuba diving, back to engineer there, but it highlights a lot of what I think we like to talk about here. Anytime I talk to like a really interesting entrepreneur, it's always a bit of a winding road. There's no A, B, C, D there. I want to get back to more of the formative years of Walden in a moment, but I'll leave it over to Mike here to ask you a little bit about the background of engineering and all that, because I think our audience wants to hear a little more of like what an engineer does and maybe like what the general kind of field is that you're in.
Before we dive into that, even I wanted to back it up just a little more because interestingly, Joe, I applied to Lafayette College. I grew up in the Midwest, and I I put my submission into Lafayette. I didn't get accepted, but who knows? We could have. I think you're just a little bit older than I am, but could have crossed paths somewhere. And I also kind of took this detour into the scuba world for a little bit too. So I'm sure on the back end of this, we could share some stories for sure.
Right on.
Yeah, diving a little deeper into environmental engineering just as a field of study, because we're hoping that we're also reaching out to people that are passionate about the environment and the things that you could do as engineers, the things that you could do with technology, the things that have been in place for decades and centuries, related to this field. But it's always interesting to me to just jump on Wikipedia, whether any topic, because I think it's this virtual encyclopedia that we have at our fingertips now. I always like going in before any session and just saying, well, what does Wikipedia say? And it's just kind of fun to see how environmental engineering is laid out in the general sense. But as a specialist and somebody who's practicing this on the day-to-day, what kinds of work do environmental engineers do? And and you could even overlay obviously with the work that Walden does, because I'm sure there's many subcategories within environmental engineering that you guys focus on, or you have a specialty in, and that you're known for. So it'd be really good to hear about that.
Sure. So I should mention that one of my I would say longstanding, but I spend a fair amount of time on it now, is the development of the next generation of environmental professionals to come into the field that's been very satisfying and successful for me.
Yeah.
And I do that in a lot of ways. Direct mentorship with students. In that role, I chair the advisory board of the School of Engineering and Applied Science. I'm an active mentor at Manhattan College, and I'm also on the executive committee of Lafayette Lacrosse. I was a lacrosse player, but I focused primarily on developing the maybe 30% of the team that's on the STEM side, which is engineering and chemistry majors and so on, teaching them how to apply for jobs and teaching them about the field and so on. So what I'm saying now will be a little bit rehearsed because I've done it many, many times. So when I was in school, at Lafayette, there was no specific program in environmental engineering. Mm-hmm. So I had to take what I would say the full gamut of civil. If you looked at your hand and it's got 5, thumb and 4 fingers, there's different branches of civil. One of those branches is transportation. Mm-hmm. So that's the design of highways and rail systems and port systems and so on. Then there's structural crosses into highways design, because you're going to design bridges for it. You're also going to design steel and concrete and so on to support structures. Mm-hmm. Then there's geotech. Geotech is the foundation design, subsurface investigations in support of building design, retaining structures, which could be earth retaining or earth and water retaining, bulkheading and things of this nature, pile systems and so on. Mm-hmm. And then you start to get into the stuff that is maybe those fingers point more towards environmental, which is like water and wastewater. So we have water distribution. So it could be the treating of surface waters for potable purposes, for irrigation purposes. It could be the extraction of groundwater for the same uses. And then the other side of that is the wastewater side, which is industrial wastewaters that was generated by industry, or domestic wastewaters, those generated by human use and so on. Mm-hmm. And then there's now stormwater, where we're worrying about the conveyance of contaminants into surface waters from stormwater.
Yep.
And then, kind of a newer branch to that is all of the stuff driven by regulations, which is solid waste. So we manage solid waste systems, municipal solid waste, curbside garbage collection, and where does that go? Right. What do we do with it? And in New York State, we have 17 defined solid waste streams. There's air, so we have discharges of contaminants to the air. So there's air pollution control and permitting. and the design of the unit operations to treat that stuff. And then there's this whole field that we'll call hazardous waste sites or hazardous wastes. Hazardous wastes are byproducts of industrial activities. They could be raw materials that, when they're lost into the environment, they create either toxic effects or carcinogenic effects, cancer-causing agents. And then when they're released into the environment, there's a set of regulations in the United States that have been followed by both Mexico and Canada, much less so in Mexico, where we have a whole system of defining the nature and extent of contamination, and then the engineering side is to look at means to collect it or contain it and then treat it.
And that's like super fun sites. I mean, that's what I'm thinking about.
Super fun sites, and then active industrial facilities. They're hazardous waste generating facilities. They're not super fun because they're still active. So that's covered under something called RCRA.
Mm-hmm.
And, so as I talked about this, you could see I went from sort of vague descriptions to much more detailed descriptions. And that's kind of like how we operate. We operate in the last three sectors, which is water and wastewater, and then hazardous waste, and then all of the permitting around that. And the permitting work can be very complicated. Whether you're a large manufacturer, let's say a power plant that burns natural gas.
Right.
They have a very large air pollution discharge, and they have treatment requirements on that discharge. And they also have a big permit that they have. And I call it a big permit because it's got a lot of constraints on their operations.
Right.
And a parallel piece that, this isn't environmental engineering anymore, but once we started to engage with hazardous materials, carcinogenic, toxic materials, people in the workplace getting exposed to that workplace is regulated by OSHA.
Mm-hmm.
And OSHA set up some rules to protect workers and let workers understand their exposures. So there's it's an acronym, but it stands for, or it's HAZWOPER. HAZWOPER is
that's a great acronym.
It's a 40-hour training requirement for anyone that works with hazardous materials or hazardous wastes.
Yeah.
And I became, in the company I worked for, I became the site safety officer, or the company safety officer, which meant I got trained in this, and then I started training employees. And there's initial training, and then there's annual refresher training, and there's supervisors training. And then, of course, our clients needed it, and we worked for contractors that needed their laborers to have this training in it. And then, so I became involved in OSHA requirements and safety.
Mm-hmm.
And then, move forward in time. One of the ways that Walden has grown is through some, I would say, strategic acquisitions. And a company I purchased back in 21 was a what we'll call EHS, but a safety consulting practice. And they work providing fractional safety officers for both construction and general industry manufacturing plants, and all matter of issues that come up in those plants, both to supplement maybe management or to actually manage the program, develop and manage the programs. So that's kind of the horizon of what Walden does. And we as engineers and as consultants respond to clients, problems and issues that develop for clients that are beyond their internal capability. Some of our clients are 20-year clients, and some of them are just one-time project clients. But that's the nature of being a consultant.
Yeah. That's really helpful to get the broader background, because civil engineering is a big category. And I think for people, younger people too, that might be tuning in, of like, what opportunities do I have? I think it was really great to hear how you laid out the different fingers and disciplines of this, just the whole engineering field, not the whole, there's lots of different paths you can take as an engineer, but yeah, getting interested in water and wastewater and these things, like it's so critical to just environmental protection and safety and overall health of people, planet. I think there's lots of things that environmental engineering touches when you really dive down and think about it.
Yeah, I think one of the things I might also suggest is that this is what I do. I mean, I get asked questions about it all the time, whether it's mommies and daddies who are looking for things for their children to potentially study in college, or students who are looking for direction as to where they should take their forward-looking choices.
Mm-hmm.
I mean, I often think it's important that a student who's studying something has work experience, so that while they're still in their studies, they can maybe refocus or recalibrate the direction they're going and take two classes that might make a difference,
Yeah.
going forward. But one of the questions I get asked all the time is, hey, is the environment better or worse than it used to be?
Right.
Huh.
And obviously when we talk about industrialization, that's kind of taken place in the last, from the 1820s or 30s, and accelerated, and whether I'm not a climate denier, but the amount of greenhouse gases that have been emitted as a result of industrialization, which includes transportation and power generation and industrial production and so on, has been growing exponentially.
Yeah.
And as a result of that, also the byproducts, and probably up until the early to mid 60s, people weren't really aware of a limitation on the assimilative capacity of the natural environment, right? So,
Yep.
when we wanted to get rid of something, we dumped it into the ground, or we put
In a
it
river.
Yeah.
into a river, or into a septic system, or into the atmosphere.
Yeah. Pretty much anywhere.
And the long and cumulative effects of that started to be felt, in the late 60s, early 70s, with massive decline in bird population or something, because eggshells were not as hard as they used to be, because they were being impacted by arsenic that the birds were uptaking.
The bald eagles, right? That was what happened to the bald eagles, was the thinning of the egg walls.
They sat on the egg, and the egg broke, and
Yeah.
wow, we can't have babies anymore.
Right.
Yeah.
And then, in recognition of this, and I would suggest slow and then very quickly, there was born, by act of Congress, first the Clean Air Act, or first the Clean Water Act, then the Clean Air Act, and then the most complicated set of regulations that were ever made in the history of the world, as I understood it, which is RCRA, which is the hazardous waste regulations, which, define what a hazardous waste is, and then require cradle to grave security of that waste. And again, one of the things I often have to explain to people who ask is, Congress, U.S. Congress, makes a law, president signs it, or rather a bill, passes a bill, Congress signs, or the president signs it into law, and then that law empowers the delegated entity, which in this case was the United States Environmental Protection Agency, to develop a set of regulations to enforce the general understanding of what the law was asking for.
Right.
The law is 20 pages long, and the RCRA regulations are 2,500 pages long, and then the guidance that goes along with it are 500,000 pages long. And this applies to very, very infinitesimal definitions of things that courts have decided and so on, but it basically is input, or has become the driver for controlling the release of hazardous waste to the environment.
Yeah.
So when somebody says, hey, is the environment in better condition or worse condition than when you first started work, or when these rules first came around, I think the answer is much better, infinitely better.
Yeah.
But I also, I'm not a but guy, and most people have not internalized or did not have a perspective on how bad it was when the
Yes.
rule came around.
Yeah.
Because things that were just normally done had changed. And, so what might have been an everyday occurrence to go into New York City and look down the street and not be able to see 5 blocks because
Right.
of smoke and so on,
Yeah.
now we can see from one end of Fifth Avenue to the other if we have a perspective that allows us to see that far. These are changes that are hard to see. But again, this, cleaning up water is you could do that a lot quicker than you can clean up the air, than you can clean up the atmosphere. So, whereas we might have started trying to control where a drum of hazardous waste went, no longer would it be acceptable to put it in a landfill, an unlined landfill. Now we are going to reclaim it or waste minimize it. The atmosphere has just been this general open body of water, but it's an air body, and everybody can dump to it. And we are no longer cleaning up Lake Ontario; we're cleaning up the entirety of the atmosphere.
Yeah. I really appreciate you bringing up this point about your perspective on, is the environment better? Because it wasn't a question that we had scripted, but it's just like, you know what, that as somebody who's in it deep into the environmental engineering world, as opposed to me, who I'm very much active in my my endeavors to help protect and have stewardship for the environment. But I just think about the pressures that are being put on this planet by exponential population growth. Like, there's just a simple fact of numbers and how many people are on this planet. But to your point, I think we're probably a generation beyond where things were extremely bad before there was this awareness around, like, look at what we're doing. Like, holy cow, this is starting to impact our daily lives, because things that we used to take for granted, just, like being able to see across, there's just things that, you're right, we're so much worse, but now they're better, but you still have these pressures of just, we're on a finite resources of this planet, and how these things are exerting these pressures. And it reminds me a little bit, are you familiar with the Jevons paradox?
No.
So it's basically the concept that when you create efficiencies, it actually drives consumption. So it came out of coal, like when they figured out how to use and harvest coal and produce and steam and like all this stuff more efficiently, it actually drove the extraction, because there was a point in the Industrial Revolution where the use of coal almost hit the ceiling, because they didn't have these more efficient ways of extracting and using coal. But then once they broke through those barriers, the use of coal just exponentially blew up, and then all the resulting use of that. And it's similar concept, because in the building world, I come from the building construction world. I went to a conference for Passive House, and they were talking about the Jevons paradox as it relates to building efficiency. And a great example was LED lighting. LED lighting is great because it sips energy compared to our incandescent bulbs. But now it's like, oh, we have these super efficient lights. Now let's cover the entire roof of an arena with LED lights. So it's kind of, in one way, is you're like super efficient, but then there's this weird psychological thing around super efficient, but it actually drives consumption. So it's like an awareness around that, and how we deal with that on the day-to-day and the macro scale of the issues and the problems.
Well, and I think something else to consider along those thinking, the irony of many things that we produce have a cost, but the cost is not fully accounted for. And, so producing electricity at the cheapest means possible, which used to be by burning coal, didn't consider any of the, coal ash, and what to do with coal ash, didn't consider, excess CO2 that was produced. And until we could put a full price to that, the economic balance between how to produce energy is, we're trying to generate cells that produce electricity, and all we're comparing them to is the cost of production versus something that has like the whole cost of production is in the cell. Whereas, in terms of let's call it wastewater, like a pretreatment system, when one of our clients discharges to a municipal POTW that has a pretreatment requirement, they pay a sewer use cost proportionate to what they're discharging into the sewer.
Right.
So that incentivizes them to waste minimize, water use minimize, process modification to generate less concern. And so there are lots of things in our economy that don't have an economic impact that's accounted for, I suppose.
Yeah.
Right.
There is an economic input or a economic problem, but they just don't account for it at the moment.
Right.
I had
And
that. Sorry.
go ahead. Yeah.
Well, I had that conversation with my teenage kids just this week about the water bill is not just you using water, but it's the heat to heat up the water and the gas that's used. And then we get charged for that water going down the drain. So it's like you're paying for the entirety of how that water comes to you. So just get them thinking a little bit about having a mindfulness about the things that you utilize and that or maybe take for granted in this world. How that the impact of that. Yeah,
it's a great point there, because I think so many people don't realize, the problem exists, but is it accounted for or not? You have lots of places that don't, where sewer is not charged, right? You're able to discharge whatever you want, at least on the residential side. So you often don't even think about that, or emissions coming from a gas stove, right? Stuff like that. You just think, oh, it's free because I'm not thinking of what it costs. But it's a great point. I think environmental engineers, you guys think about that stuff and deal with that more than anyone. I do want to bring it a little more forward as well, Joe. We care much about the sustainability side of things, and we're also like a remote sensing and technology podcast on the other side. We're an interesting mix here. And I think talking about how you monitor, how you account brings up, as always, our favorite word is GIS. Like when it comes to our favorite acronym, at least Mike and I. And when you're looking at how you account for this stuff and how you measure and how you do the analytics, often we see that's where remote sensing comes in, right? That's where you look at how you actually account for that stuff. So as I understand it, environmental engineering and GIS have had like a long history together, right? So I'd like to ask you a little bit, maybe you can even give your flavor of how Walden evolved and again, how it started and what your first work was. But also if you could tell us a little bit about how long have you been using GIS and how did that journey start, that you did this analytical analysis here to...
Yeah. Okay. So, this will go back before Walden.
Sure.
One of the clients that I used to manage lots of work for was CSX, which is a national freight carrying railroad, class 1 freight carrying railroad. Their current system covers about half the United States. And a lot of the work that we were doing for them at the time, this is in the early to mid 90s, was consolidation of what had been 3, 4, 5 different railroads that were all now operating under a single title, CSX. Old coal and I suppose before that wood-fired locomotives ran boiler systems and boiled water, and that's the way they powered their trains. So yard facilities had to be close by. So maybe a fully loaded train with a coal tender could travel 100 miles before it needed to be rewatered. Its boilers had to be replenished with water to be boiled into steam. So there was a lot of yards. And then as they transitioned away from that form of locomotive and worked more towards fuel, burning fuel, the amount of water required for that obviously disappeared. But then they had to put in fueling stations, and the locomotives maybe could travel 300, 400, 500 miles between areas they needed to refuel. So of course that meant there was a lot of orphan yards, and these orphan yards, orphan meaning unused rail yards. There's yards are areas where they do maintenance on the train system itself, the locomotives. They also switch out they build trains and break trains apart as the cars, go in different directions. But in this course, they had about 2,200 yards, and of which they maybe had operational yards of about 400. So a lot of these yards represented a lot of important industrial property, and they were looking to reclaim that, what we currently go by the term brownfields, right? We term brownfield, reuse a piece of property as opposed to take a undeveloped piece of property and build something industrial on it. They also were adjacent to the main line of the rail system, so they had heavy, rail access. So we did a lot of demolition projects, and we did a lot of cleanups. And the primary contaminants at these yards were either industrial solvents they were using when they were doing work on the locomotives, or diesel fuel, because diesel was the primary fuel of the rail system at that time,
right?
And I think to this day.
Yeah.
So what I was doing is, at any given time, I might be managing 10 to 20 rail site investigations. So we'd send people out and they'd collect data. When I say collect data, they'd drill some holes in the ground and put in monitoring wells, and they'd sample those wells, and we'd identify where they had what we call free products, or like diesel fuel floating on the water table. And we'd take records of all of this, and then we'd synthesize this into a site conceptual model so we could understand what the problems were. And then eventually we would design some kind of a remedial system to deal with that, either to control what was there or capture it, or fully abate it, let's say. So I sent people out, for 2-3 weeks at a time, and all of the information that they would gather in the field was captured in notebooks, and then put, water samples and soil samples put in jars and sent to laboratories, and labs would send back data, and we'd get essentially Excel sheets of data. And then for weeks at a time, this data would get synthesized into stories to allow us to explain what was going on to our client and to the regulators who were asking us to do this work or demanding this work gets done. And I always thought that this was a fully redundant system. We were doing things and doing it again and then doing it yet a third time. And we were making flat data tables, so we would turn it into Excel, and then it looked pretty, but we couldn't interact with the data in any way. So one of the first things I did when I started Walden was I was looking for means that we could both synthesize the data in a smarter way, but then also represent the data in a smarter way. So, and again, we used to take maps that we'd have a surveyor create, and then we'd draw plume representations on it to explain where the contaminants were going. And again, this was all like in 2D.
You had some cartographers working with you too.
Yeah.
So
exactly.
Yeah.
And of course we were interacting. Some of this work was in West Virginia or Western Pennsylvania or Kentucky. So we had to find a local surveyor who could survey the area, and it became lots of work. So at the end of the first year of Walden, and part of starting Walden was, aside from a desire to do it, was I had, they were approximately a year and a half old. I had twins, and my ex-wife used to travel a lot, and she's traveled out of the country a lot and was away for, a couple weeks at a time. And I would be on the road doing what I just described, or overseeing what I just described, so that, we had a nanny or somebody's watching our kids, but oftentimes not somebody, a parent wasn't always present every day. And that wasn't ideal. So I recognized that, of the two of us, I could probably pivot easier and work closer to home. And so that's kind of one of the drivers too. So after the first year, I took the company profit and said that I wanted to find a tool or several tools that we could put together in a combination to aid our ability to process and utilize data and then in turn represent that data to clients. So I went out and looked into some various tools that were out there, and I say tools, this is software.
Yeah.
And I
And this
settled
is
upon
30 years ago. This is
Yeah,
Yeah.
it's like
Yes,
Yeah.
1996,
Yeah.
97, just to give the
Yeah.
audience a timeline, right?
Yeah.
Yeah.
And I should say that in earlier life, I had taken some data based classes in a potential computer science master and had a fairly good understanding of how data systems operated. Just
Yeah.
didn't, and had done some, I think at the time it was called D-based programming.
Mm-hmm.
And but what I started to see was there was the ability to mesh map-based information into the data set. So the data set would be tied to the map in some way.
Yeah.
Conceptually, I didn't understand that was called a GIS until somebody explained it to me.
Yeah.
So as I said, I eventually bought a piece of software called GIS Key, and then we also bought another piece of software called what was it called? 3D visualization software, but I can't recall what it was called at the time.
Mm-hmm.
And the idea was that we would take the data we collected, enter it in tablets in the field. We'd receive data, which was now starting to happen from the labs if you asked for it in a format in a electronic data deliverable, so we didn't have transcription errors. And then we could manipulate in the data system and then export it into the 3D software, which we could then build AVI files, movie files to demonstrate the data to our clients so they could be better informed and make better decisions. And a young woman, one of my first hires, came along with those ideas. We worked on this system together for quite a long time. I didn't know very much about marketing, so we coined the service DB3D, database management and three-dimensional visualization, and started to work towards pushing that out into the internet. And much later learned that when you brand with a nonsensical acronym, nobody's going to be looking for it, right? And that was quite a painful lesson when I finally came to that realization after the fact. But we did sell a number of projects where we did just that. We collected we generated three-dimensional imagery of data sets that others provided us or that we collected on our own. And again, that was my first dip in the finger into the use of GIS. Obviously, we've followed the developments of environmental GIS systems, whether it's ArcGIS or some of the other more proprietary systems that run out there. And again, we've watched laboratories become much more sophisticated in the way they manage data through their LIM, which is a laboratory information management system, and how they can export, and how regulatory agencies now have expectations on export, format export, and so on. And we've also watched as our clients and regulatory agents now want data digitally. They don't want reports in paper and pretty pictures on paper. They want it all digitally. And it doesn't take too long to find, if you want to read about your local Superfund site, you can go to a out-facing EPA site or DEC site and pull up a world of information that formerly you'd had to go to Albany to get or something.
Yeah. I think a common theme that Scott and I continue to see in our conversations and hear about is how GIS, people tend to have this aha moment. It's like, oh my gosh, it makes so much sense. You have this three-dimensional database that's place-based. And we've probably said that phrase many times in this podcast, but it's being that it has become so much more intuitive to use as a software and accessible, and other agencies, whether traditionally government agencies using this type of software and technology. Now more private institutions. There's just more and more people are starting to feed, and obviously there's exponential amounts of data that is being collected every day. So just GIS as the glue that really ties all these together for so many industries, I still feel like we're scratching the surface on how people are going to use this technology. Not only from the engineering side of things, but just again, private institutions and just managing their assets. And I think it's pretty exciting to hear how it even sounds like you are pioneering to an extent some of that 3D visualization back in the day. And now look where it is. Like, what are some of the most exciting things with today's GIS technology that you guys are using it for?
I mean, this is a very much a switch of gears, but consulting practices gain clients through a number of ways. One of them is what we'll call a formal request for proposal process. So somebody, typically the government, but somebody will post a request for proposal, and then we digest what they're asking for. Sometimes they'll have meetings to discuss what they're looking for. They'll make some changes after they get input from guys like us. And some close to 3 years ago now, we responded to a New York State Environmental Facilities Corporation RFP looking to hire consultants across the state of New York to do what they called asset management system development. And as I understand it, the state of New York has, through grants and revolving loan funds, loans monies to municipalities to build and maintain capital project money for water and wastewater infrastructure, and many other types of infrastructure projects, but those specifically I'm aware of. And when the infrastructure that they've lent money to is poorly maintained or underperforming, if you were the bank and you had a loan, you might call the loan, right? Or what do you call, foreclose on the property in order to get your money out, so to speak. The state of New York is not going to go very far if it starts trying to claw back monies it gave to Utica, New York, because their wastewater facility isn't working properly. So they've decided to do something else, which is we believe anyway. So our RFP was submitted to the New York State Facilities Corporation, EFC, and we were awarded a project, or 3 projects, as were 9 other engineering firms, big and small. I think Walden might have been the smallest of the group, and we were awarded projects to build asset management systems for 3 sewer districts in the state of New York. Again, as I understand it, there's over 900 sewer districts and water districts that have received EFC funding. And having worked for municipalities for many, many years, I understand, since the beginning of Walden, I understand that, there's a significant gradation between the level of responsibility and O&M care that these municipalities place on their assets, similar to any neighborhood where you see, gutters falling off houses and broken windows versus beautifully maintained houses. So the problem, of course, with the municipalities not maintaining their infrastructure is they are supposedly the stewards of their communities by, whether they're through elected officials or just through, they pay for it through the taxes they collect from you. So your expectation is that their stuff isn't falling apart.
Sure.
So anyway, we've been, it's a pilot program. There's 30 municipalities that are part of it. There's 10 consultants, and we're being taught by EFC how to build an asset management system. it runs on some complicated IBM software called Maximo, and part of the system is uh, inventory of all assets within the entity. So if it's a sewer district, it's all the pipe, all the manholes, all the treatment works, and so on. And then a relative level of service judgment. So we look at a pump and say this is at the end of its service life, or it's not at the end of its service life. We do a replacement cost analysis. We do we're attempting to match the rates they charge for the sewage treatment to the costs associated with operations, and the whole system is linked through a GIS. So every piece of asset within the district is three-dimensionally linked to a GIS, which is the key. Maximo draws its data out of a GIS.
Yeah.
So we've been very fortunate. We work with Scott and Harkin on doing some of the GIS work that's associated with the project. And, again, the digital nature of storage and maintenance of information in a digital system is so much better than, we started this work by scouring for as-built drawings of stuff that was built in 6 iterations. And, the map room had a flood, and that consultant that did that design is no longer in business, and so on. And, the value of, we use the word as-built all the time, but the value of up-to-date as-built is invaluable.
Yeah.
And it sure is a lot better if we have a digital representation as-built to modify than it is, paper and pen version.
Yeah.
So, again, that's 2 GIS uses, potentially very different, but all based on the same system. And that's kind of the tie for it all is it's map based, or it's 3-dimensional imaging based.
You said you think you may be one of the smaller firms that were awarded the contract. And I think the really cool thing about GIS here is that doesn't matter, right? It's thousands of assets, it's thousands of manholes and pipeline, but you don't you can get a lot done without the physical resources that I think you used to need. Like you said, having the place to store that stuff, having a map room, having all that, you can kind of maybe punch above your weight class, so to speak, and really tackle these big projects, regardless of your, the firm size, because GIS is letting you do all of that so much faster. At least that's what I've seen so far on this project. Got a lot done.
And something that caught my attention that you were saying is this data is 3D, because I think GIS is getting much better at expressing 3D data than what it used to. Yeah. But I know there's a huge push and issue with underground utilities, specifically in this country. I remember I heard some statistic. It's like $9 billion or something of that order of magnitude that results from hitting utilities, and the impact that might have on not just the cost of replacing that utility, but the slowdown on a project and schedule delays and all of the resources that go into managing some of these issues. So, the proper documentation of those things in the 3D space, you're capturing accurate IEs in the 3D, obviously you can put an IE on a drawing in a two-dimensional plane. But I think seeing these things in 3 dimension, and then my brain's kind of going to this building construction world where you have all the BIM modeling and clash detection of a 3D design. So the more I feel like we're getting closer to having that in the underground world be closer to a reality. I don't feel like we're there yet, but you may correct me on this, Joe. But I feel like there's still a lot of work to do in this 3D mapping of the as-built world, and even seeing some of the technology that's coming out now, where it's just easier for someone to maybe even use the LiDAR scanner on their iPhone just to capture a trench or a utility as it's being placed, because nobody likes to leave trenches open for a long period of time, right? They're laying pipe, they're laying sewer. It's like, lay it, inspect it, cover it up. Let's move to the next segment of this pipe. So it's not like you have this moment in time. It's like, hey, let's bring a drone out and let's map the entirety of these open trenches. It's like it's a stepping stone process. So like the ability to capture these now, and I was, and I'm, this is kind of fresh for me because they were replacing the sewer outside of my house last summer. So that, you know, they're out there making all kinds of noise and doing their thing, and I went out there and I was like, are you guys capturing this as you're laying this sewer pipe down? Are you capturing it any way other than just taking a survey pole and measuring your IEs? And they're like, no, we're doing it. And so I was like, it seems like a golden opportunity in today's age to that every municipality should be documenting this more accurately with some 3-dimensional data to feed into these systems. So like from where you sit, how far are we along with that endeavor as far as capturing these, whether it be an as-built of an existing thing that maybe you're unearthing for environmental engineering reasons, or new construction projects? Because I don't know how much work that you guys endeavor upon that's new construction or new utilities and such, as opposed to like existing.
Yeah, I mean, let's go back to the original statement that I was making about how stewardship of infrastructure is oftentimes the last thing that anybody pays any attention to.
Mm-hmm.
You know, I'm sure at some point we'll talk a little bit about where things are going, but you know, people buy, I mean, this is an example. People buy cheap cars because the car is cheap without consideration for what's it going to cost to maintain and operate.
Mm-hmm.
Right.
So, you know, if you pay, you know, we'll use gasoline and gas mileage, but if you buy a cheap car that gets 12 miles to the gallon, the total operating costs over 5 years might be way more than if you bought an expensive car that got 35 miles to the gallon.
Right.
And the pay as you go cost part of operations isn't often considered in the overall project plan. So you know, when the sewer line gets put in, that you're just describing, or the gas main or whatever it is, you know, maybe 5% of the total cost of the installation, or maybe less, maybe 2% of the installation could be developing a good 3D as-built that will stay with that project forever.
Yeah.
And allow for useful infrastructure planning of the next job and the next job and the next job. And yet, you know, it's, I would say in a lot of senses, it's the short-sightedness of the owner or the designers to not include that, right?
Yeah.
You know, at the end of any given job, I've done a lot of wastewater plant designs. A lot of times we are asked to put in our specification that the builder, the contractor, has to prepare an O&M manual. And that O&M manual generally comes in with our drawing set, no as-built modification to it, and cut sheets essentially of the equipment they supplied. No parts lists. You know, it's again, it's the last piece of work they have to do for the job. It's the thing they do with the least effort. Train up operators into the new equipment is not done, so that everybody's starting from scratch every time we do a new job.
Right.
You know, considering the fact that if we did, so I'm saying all this to suggest that a lot of times owners need to put a premium or a value on this
digitization of the assets.
Yeah. And you know, we've worked for a lot of companies that are owned by private equity, and they don't view 40-year histories. They view 3-year cycles or 4-year cycles where they're going to unload the assets they hold and sell them to somebody else.
Yeah.
And that cycle doesn't stand for investing in the infrastructure.
Yeah.
We work up at an IBM plant well, we work at two old IBM plants, and the amount of as-built information and the quality of the construction was remarkable, because IBM was, I mean, when they did all the work, they weren't planning to go out of business. They were planning to be in
Right.
business for the next 100 years.
Yeah.
So it's just a mindset. And I mean, I don't think, I commented about, a view on the engineering educational process. As the fingers of the civil engineering hand get bigger and bigger and longer, the amount of time that can be spent in that education is, on concepts like what we're discussing isn't there.
Yeah.
And clearly, if the decisions are being made by elected officials, they don't go to elected official infrastructure planning school.
Right.
Mhm.
Right.
They aren't too worried about that stuff. And I think it's really important that, as stewards of community owned assets, that these things get done.
Yeah. And
You
I
know,
think, yeah, go ahead, Mike.
Well, I mean, of course, Scott and I are both in the business of reality capture, and we're big advocates of capturing as-built information as you're going, because it just makes sense. And I think we're touching on this in a big way right now. It's like, it was interesting, Joe, to hear your perspective that there are these business pressures on this exact issue. It's like, well, if you have someone who's going to sell this asset in 3 years, there's the incentives to spend that money thinking 7 generations down the road, or 100 years down the road, when this infrastructure is going to need to be replaced, or something breaks 20 years from now, and you have someone digging through paper files or even digital files now, but that are still a bit rudimentary compared to what they could be. It just, I mean, again, a little biased, Scott and I think all three of us probably a little biased, but it seems like a no-brainer that specifications should be written in such a way that it's a requirement to capture as three-dimensional as-built information through digital scanning technology, to have these things recorded and documented well.
Yeah. And I'll add that I think my optimistic hope here, and Joe, you can probably, maybe our like timeline of work together might be a testament to this, is that the cost of doing that 3D capture is dropping drastically. It seems every day we're seeing a new scanner hit the market, a new thing. Now your iPhone can capture 3D LiDAR. And I think, Joe, you might recall like our history of saying, oh, should we laser scan that? And that went from like, oh my God, that'll cost like a few $100,000. There's no way it'd be bigger than the project budget, to now where this is becoming such a commodity that it's almost becoming, it's not quite there yet, but it's almost becoming the same cost that it would do to hire a drafter and do a 2D plan set. And so that's my hope. My hope is not that, yes, we need a sea change in the people who are in charge of this, and the property managers and the private equity firms. But I think as time goes on, the cost will continue to decrease to the point where it is a no-brainer, because they're not looking at it as a line item. It is that 1% of the total budget. It is that barely, 0.5% of whatever it takes to build or construct something.
Or some crusader will identify, any number of poorly pre-design identified, use the word clashes, but I think of a project like the reconstruction of a terminal system at Kennedy Airport, and recognize that there's probably thousands of design sheets and hundreds of thousands of design hours that went into that, and yet somewhere along the line they'll hit a buried jet fuel line that was there all along, and it'll delay the project, and that cost of delay will be potentially millions of dollars. And if they took all the design effort and then built it all into one big 3D model, those clashes would have been identified, and that delay could have been avoided, and project sequencing could have been reconsidered, and this is what big projects are going to have to maintain, sort of cost effectiveness.
Yeah.
Again, I'll also go back to, what we're talking about are specialized skills that are developed on the job within the industries that we represent, and obviously on the MEP and mechanical side and structural side, all of this is going on. I think even, this is back to what I know about the university systems. These topics are so, they're important to us, but from an educational standpoint, and this is one of the things that I'm really interested in, is curriculum advice. Like, as the civil engineering department graduates civil engineers, they have to meet requirements established for them by ABET to stay accredited. And yet, I'm on the industry side saying, hey, I need my civil engineer from Hofstra to have been trained in this. And they say, well, we can't fit that into our 128 credit hours that the degree requires. And we can't expand the degree into 4.5 years or 5 years or whatever. So, there's more than ever, there's so much that we expect out of a young, educated civil engineer, environmental engineer, whatever, that, it falls on me and us to post school graduates, teach them these things that are potentially wholly unheard of until they show up in the workplace.
Yeah.
Maybe it's always been that way. I just see it more and more, an environmental, this is my pet peeve of all. My environmental engineer shows up, and that environmental engineer is going to do design work. They're going to build remedial systems. They're going to design and build wastewater treatment equipment and so on. But they have had zero exposure to soil mechanics or concrete or steel design, because that's civil engineering and not environmental. So they don't even know how to design the concrete that they design a tank to treat water in, and it's a concrete tank, and they don't know how to build the tank.
Right.
And, so now I have to have what, the vernacular is a multidiscipline team. I have to have a structural engineer working with an environmental engineer to do something that, may have been something they could have learned together.
Yeah.
One student could have learned both.
Yeah, exactly. And then they got to do that. They have to draw all that up in AutoCAD to provide plans. And then they've never, maybe they've had an hour of CAD experience. So I run into it.
Well, they've had Revit, they've had SolidWorks, they've had 1 semester of CAD, and it's got AutoCAD, Revit, SolidWorks, and ArcGIS
all in 1 semester.
Yeah. Yep.
And now and every one of them says, I'm adept at this, that, and the other thing. And then we give them a drawing test, or they can't do it.
Right. And
this is interesting. I think this topic deserves a little bit more focus, because it is certainly a common theme in all the folks that we've been talking to, that there is just a shortage of qualified good help in the STEM world. We hear it about surveyors, we hear it about engineers. Like we need more people feeding into this systems. And we've had discussions like, what are some of the ways that we can promote that at the high school level and get more people interested in trade schools but just thinking about the constraints that are on universities from a curriculum standpoint. And I think that was a great point you were saying. It's like, well, there's practical things that have changed as the result of the industry, and that have changed as a result of technology. So what are some things that are maybe not as relevant anymore in the curriculum that's being still taught today? Because I think some institutions aren't really known for being really nimble with their curriculum, but it's like, okay. And I'm also framing this in the even larger context of how AI is starting to come into, because I have a kid that's going to be in college in a couple of years, and I'm like, well, how the heck are these institutions keeping up with how AI is changing the workplace, and how are they, changing their curriculum that's going to make sure that this college education that she's paying a lot of money for is going to be relevant when she's done. So it's like how they need that input from industry professionals such as yourself to come in and provide this input, but then I'm sure there's some process that they have that if we hear enough of this from enough industry professionals, we're going to add this to our curriculum and we're going to drop something that's less relevant. But I think it's like, where is this line in the sand of like, this is what we should be providing as an educational institution, and this is what you actually acquire in the real world application in the workforce once you get out.
Yeah, so I should say that although not an alum of Hofstra, I grew up, I say 6 blocks from Hofstra. My father was a graduate from Hofstra. He had been involved in alumni things at Hofstra for years and years and years. And, about 11 years ago, maybe a little longer than that, Hofstra's engineering degrees were under the School of Science.
Mm-hmm.
And at the time, they had a sort of forward-looking president who decided that they should, and you may have heard they have a medical school now, they have a nursing undergraduate and graduate school, and they have always had a law school, but he was interested in forming a school around engineering. So about 10 years ago, SEAS, the School of Engineering and Applied Science, was born. And I had sort of started working with Hofstra prior to that. And, my interest was, one, it was a little bit helping my dad out and what his interests were, and, local work. I mean, going down to Lafayette is a long day, one way back down and back.
Mm-hmm.
My interest was, I had people with degrees from Hofstra. They were called, you have a Bachelor of Engineering Science with a concentration in civil engineering.
Mm-hmm.
And I remember getting resumes that said that. And I said, I don't know what this is. So I didn't interview the kids, and they weren't graduating that many students either. At the time, they were graduating they had less than 200 students that were in engineering and applied science school under science. So I remember sitting with the school president, and we were talking about the formation of SEAS, and they were looking to hire a dean, and we had an inquiry out for deans, and ultimately we hired a fellow from Cooper Union who left Cooper. He was the dean of Cooper, Simon Ben-Avi, his name was. And Ben-Avi and myself and an engineering professor and the president were talking. And I said, one of the things that's really important is that the curriculum supports students obtaining the professional engineering license. I mean, right. You heard I'm a PE.
Mm-hmm.
And so that means their degree has to be accredited. That's the pathway forward to get licensure.
Yeah.
And he said to me, he goes, "What's PE?" This was the president of the university.
Mm-hmm.
So I had to explain to him that, it's professional engineer. It's like passing the bar and you get admit, I get it. Yeah.
Yeah.
And then I said, and this degree that you guys are giving us, engineering science, concentration thing, is not appealing to the people out there. And I said, if you want me to be a part of your school and work with you guys, one of the things you're going to get is a lot of strong opinions, and it's going to be from me looking at you, not you looking at the workplace. Like
mm-hmm.
It seems at times, it seems as though they don't look, and I don't mean Hofstra. I think in general, educational facilities don't look outward and say, what is it that people need?
Right.
Yeah. So we set a plan forward to change our accreditations. Now I think there's 6 engineering accreditations. Civil engineering is accredited, mechanical engineering is accredited, and so on. And then there's 4 CS degrees that are accredited as well, 10. But what we learned along the way is that accreditation process is that archaic thing. That's the thing that says that this is what is it's necessary to teach in order to keep that accreditation.
Yep.
I also think that we have a kind of balancing act because it's hard to teach structural steel design 2 if you haven't had strengths of materials or natures of materials or dynamics or,
Right.
and Scott had all those classes. And so it's like each class builds on itself. So it does tend to layer expectations on
Mhm.
top
Yeah.
of it, which, it's, you can't really water that stuff down.
Yeah.
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 And,
That's
so I'm really good at pointing out needs, and sometimes those needs can be balanced against dropping some, electives that might have been taken in, what we used to call gut classes to get a good grade in classes. But eventually you might have to add credit hours. And the
yeah.
drive is really to get people through school in 4 years and drop credit hours.
Yeah.
So,
And
that's that's the dynamic of things. Mom says, "Hey, I'm going to buy a 4-year engineering degree for my kid. He's got to finish in 4 years. We don't want him failing, and we want him to have a job when he graduates. And we're going to balance that job versus, my other kid who's got a degree but he got a job for private equity. He's getting paid 3 times as much.
Mhm.
hmm
You
yeah.
know,
Yeah.
And
that's also it's the risk and return for that engineering degree.
Yeah, you bring up such a great point there because I have had a lot of high school teachers like approach. I do a lot of education, a lot of outreach too, and they'll say, "Oh, wow, what should I tell my students if they want to like do drone mapping like you do?" And my answer is always, "Go get the 4-year engineering degree. The drone mapping side seems cool, but if it's one thing we have a big I think we're struggling with right now is we have people who want to go and use the tool, but then don't have the underlying understanding, right? And have no opportunity to pursue licensure, like you were saying, because they didn't think about the foundational part of it first, right? Going to an A-bit accredited school. And I'm not saying every person has to go to an A-bit accredited school. Like I said, there's all different walks of life, but that is the struggle I'm personally seeing right now too. I'd love everybody working for me to drone work to also have going to an A-bit accredited school, because I think the whole drone mapping field should be pursuing licensure in some way as well. Maybe that's a PE, maybe it's a PLS, maybe it's a third thing, but we
some
all
sort of
have this.
technician or something.
Yeah, Mike
Yeah.
and I talk about this all the time. We have this responsibility to provide good data to you, Joe, right? To people like you. And you have a responsibility to your client to do a sound engineering design. So, where does that fit? Where does all these new technologies fit with the responsibility to be part of a good capture and design and follow the ethics and the professionalism that a PE or a PLS or, any licensed engineer has? So you really hit the what I would call the hot potato right now, I guess, of the industry, at least as far as Mike and I discuss, because we're talking about this all the time. Can anybody operate drone mapping, or is this more under the professional purview of a PE or a PLS? And it's just one, like maybe it's a six finger, call it, of the entire scope of engineering there.
Yeah.
Yeah, I mean, when I was an undergraduate civil engineer, we took surveying,
Right,
and
right.
I mean, this is before digital tools even existed, so we were
Yeah,
surveying by hand with tapes and tape
Metal tapes
corrections
and
and all
yeah.
this sort of stuff.
Oh,
exactly.
I did that too. I love that class. That was a lot of fun.
But I think the essence of things like that is it allowed me anyway to start to see things. Like I've always said to people, I mean, engineering, GIS work, and so on, for somebody to do it well, you also have to have a, a, a model of what you're looking at or mapping that can exist in your own brain.
Right,
And
right.
certain people don't have spatial awareness like that. I
Mhm.
can look at a site plan and I can see things in it, obviously from practice, but I also think because I started learning how to survey, I can see stuff in 3 dimensions on a drawing that other people don't see.
Yeah.
That's a cultivated skill. I believe that.
Yeah.
And if they say some people hear music and can see notes on a page. I can't, but I can
Mhm.
see stuff in 3 dimensions. I think, it's certainly not for everyone, right? You and Scott, you and I have talked about this. I mean, there are people that do drone, they use drones to create, accident reconstruction stuff,
Yeah.
and sometimes those things become cartoonish because they don't have any tie to reality. Like they just represent a picture that works, but they're not digitally or dimensionally accurate. And if you lose that, then everything is more like a game instead of of representation. And again, that's really important, because when we put stuff in 3 dimensions into a digital model, if we lose accuracy, then the model is useless for everybody.
Yeah,
exactly.
And God knows there's been ample times where people fake data, and if that's one of the tools that we get our jobs done that way, and no one's going to notice this as-built condition for 30 years and I'll be long gone, that's where part of the engineering education is also ethics, right? We get taught that when we put our stamp on something, or when we make a statement, it's to our best professional knowledge, it's accurate. And it's a life safety issue as well. If we design if we cut corners on a weld or on a beam or something, and it results in a failure, that's on us as a professional. And that's what also keeps us working within what we know. We slowly expand, but we don't go out and try to do, soapbox here for Heaney. But, there's plenty of people that work in my profession that aren't tied to any form of professional ethics, because they're unlicensed in anything. And they can use that, whether they're knowingly doing it or not, they use that to their advantage. Whether it's the way they estimate job costs, or hide costs within jobs, or how they interpret data truthfully or otherwise. And of course, that's what sometimes reputationally drags the whole industry down. And so I'm a big advocate for some form of ethics training for anyone who works in any of our fields.
That's super critical. It really is. Yeah, man, I think we can really keep going on the educational component and the importance of licensure, and just how that all makes the industry safer, and just it protects people. That's the right, like do no harm, like kind of that's where we're all coming from. But I do want to be mindful of time for you particularly, Joe. Just I know we're all busy, but zooming back out a little bit, I think we want to try to bring us in for a landing here. We always like to ask a final question to our guests of, is there something that inspired you or that had a huge impact throughout your career that you could share, whether it's a book you read, an experience you had, that it's a call to action. Like we like to leave with some inspiration. We're focused on solutions. We really like to end on this high note of what inspired you, what gets you up in the morning every day, what is something that'll inspire others to kind of move forward with.
I mean, I think I'll answer that in 2 ways. When I went to Manhattan College had a very seasoned, well-respected environmental engineering professorship. The professors, there were 5 of them at the time. 4 of them were nationally known, and one of them was Dr. O'Connor. And as an undergraduate, when I did one section in a surface water class, I had something called the O'Connor-Dobbins reaeration formula, and used this formula to solve for the speed by which a surface water will reaerate. So reaeration means how much oxygen is in the water up to oxygen saturation. Okay. And this was Dr. O'Connor's PhD dissertation. This formula was derived. So he was an older fellow and used to smoke a corncob pipe and talk to us and so on. And I remember, let's call it a hot April day in the Bronx, listening to Dr. O'Connor lecture. And at the time, he was also serving as a national on the a science advisor to President, maybe Reagan, I'm not sure,
Yeah.
and on water quality. And he had a personal data set of water quality that he had paid research assistants and so on and gathered for like 40 years of New York Harbor.
Wow.
And all sorts of monitoring points all throughout. And he had built models of it and so on. And at that point, the city of New York was producing primary treatment only and was under a substantial consent order from US EPA to put in secondary treatment. They have 13 wastewater treatment plants. The cost of upgrading the secondary treatment was enormous. So they decided to pay the fine. The primary sludge, they used to take it offshore and dump it in the ocean, 12 miles offshore. So anyway, Dr. O'Connor said to us, he said, our generational challenge was first he prefaced by saying that all end of pipe treatment technologies had already been thought of and were well in hand. So in other words, the city was going to put in secondary treatment, water was going to improve because of that. But our challenge generationally was stormwater, not non-point source of waters, whether they be industrial runoffs or separation of combined sewers.
Yeah.
And I know that he just sort of said that, and then we just like sat there for a minute. And I remember afterward, couple of my buddies that I was in class with, we walked out and I started talking about that. And I said, that's a really interesting statement from a guy who's been like, the O'Connor-Dobbins work was done in the 20s, like 29 it was published or something like that.
Wow.
And he said that our challenge was there. Yeah. And now reflecting all the way back to those statements, what we now commonly call stormwater regulations and MS4 programs, and you probably map some MS4s and stormwater outfalls and so on. These are all now, I don't say standard practice, but we're doing them. Mm-hmm. And again, as I say, do we have a full understanding of the water quality impacts that's done versus what it used to be? Well, our perspective is only what we see today, right? And Scott's from Oyster Bay. We know that after it rains, the clam beds get closed for a couple of days because of bacteria releases and so on. Well-maintained stormwater systems with good BMPs, best practices in place would not lead to that. So we're still rolling these things out.
Right.
And, that's quite interesting. But, I guess it was just a generational challenge.
Yeah.
And then I think, the last thing I've been talking about it all along, I mentioned that I've been practicing, I'm 61 years old. I've been practicing for a long time. More so than ever, I enjoy spending time with the junior folks, trying to get them engaged and thinking the right thoughts and be motivated to learn the new stuff or learn stuff they don't know. I always say that people picked, like, nobody went to college, university to study environmental engineering and graduated with that degree or mechanical engineering, because we know that's a hard route. Nobody did it and finished just to say they did it. They had something that motivated them to do it.
Right.
So then they go out into the career somewhere, and somewhere that interest or motivation, is either going to get encouraged and grow, or it's going to get dashed.
Yeah.
And when you meet somebody that has that degree and they're working in something and they whine about the job they have because it's not what they thought, I say, well, but you started with the right idea and you started with the right tools. How did you go down that road? How did you get to where you are now that you're not interested? And, I like to tell people, I've been doing this a long time. And I mean, people say, I'll be completely honest with you. And of course, that's like some signal to that they normally have been lying, right? But I think since I started working in this field, there's really never been a day that I've been disappointed or felt that it wasn't interesting or there was some thought-provoking thing that happened.
Yeah.
And so now when I talk to people, again, sort of, I'm not old yet, but I'm getting there. I always say, hey, if you got anything out of this discussion, play it forward. Do the same thing for somebody else someday.
Yeah.
Maybe not today, maybe not 5 years, but recognize that our field has so much knowledge it needs to transfer. You have to be a part of that transfer. Don't hold it close, and maybe you're going to just encourage a kid to go out there and do better or more than you did.
Mm-hmm.
So,
Yeah.
that's what
Yeah.
I'd leave you with.
Great.
Yeah.
That's as good as any, because you've certainly transferred quite a bit of knowledge to me. Again, Joe, I consider you my business mentor, and the amount that you've imparted on me has helped make me successful. So I think that's a great one to end on there.
Yeah, definitely. Just so critical to pass that knowledge, and grateful for the work you're doing, Joe, and grateful for the time you've spent with us today to talk about Walden and just all the kind of the ins and outs of environmental engineering and things that are critical for the people, the planet, and just mentorship. So all around awesome conversation. Thank you so much for your time. And man, I'm looking forward to keeping track of what you guys are up to. And by all means, we can always talk about having you back on sometime in the future. It just seems like there's tons more to talk about, but
all right. Thanks a lot.